Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Structure I is a bicyclic compound, norbornene-based, with an anhydride bridge. It has two CH3 groups and two H atoms on specific stereocenters. Examining the molecule, it possesses a plane of symmetry, or C2 axis, that makes the two halves mirror images of each other internally, rendering it a meso-like or achiral compound. The molecule has an internal symmetry element, so it is achiral. Moving on to the next step. Structure 2 has two stereocenters, C1 bears CH2O, ClH, and C2 bears ClH, CH2O. Both stereocenters are present. Checking for internal symmetry, the two ends of the molecule are CH2O groups, but the stereochemistry at the two centers as drawn does not create an internal mirror plane. They are not in a meso relationship. Therefore, structure 2 is chiral. Moving on to the next step. Analyze structure 3, Fischer projection, aldopentose-like. Structure 3, CH2O, O vertical bar H, O vertical bar H, O vertical bar H, ChO. This is an aldotetrose or aldopentose with all three OH groups on the left. With ChO at the bottom and CH2O at the top, there are three stereocenters all with the same configuration, all OH on left. Checking for internal symmetry, the top and bottom ends are different, CH2O versus ChO, so no internal mirror plane exists. All three stereocenters have the same relative configuration, but the molecule is asymmetric due to the different end groups. Structure 3 is chiral. And for the final step. Structure 4, CH2O, O vertical bar H, O vertical bar H, O vertical bar H, CH2O. Both ends are CH2O, identical, giving this molecule a potential internal mirror plane. With all OH on the left and identical end groups, there is an internal plane of symmetry making it a meso compound. Structure 4 is achiral, meso. Structure V is a cycloheptane with CH3 groups at the two alpha carbons. One CH3 is on a wedge, coming toward viewer, and the other is on a dash, going away from viewer. These are on opposite faces. This trans relationship means there is no internal plane of symmetry bisecting the ring through the carbonyl, because the two methyl groups are on opposite faces. The molecule cannot be superimposed on its mirror image. Structure V is chiral. Chiral structures 2, 3. V achiral structures. I. Internal symmetry in bicyclic framework. 4. Mesoalditol. A. I. 2, 3. Incorrect. I is achiral. B. 2, 3. V correct. C. 2, 3. Incorrect. Mrs. V. D. I. 2. Incorrect. I is achiral. Mrs. 3 and V. Therefore, the correct answer is B. Therefore, the correct answer is option B.